already one radical is isolated on one side and everything else is on the other. So what do you recommend we do here? To solve this equation. Excellent, thank you. We have to square as one unit on the left and one unit on the right. Do not do this. 7 squared, x squared, this squared. No, no, no. The left-hand side is 1 unit squared. The right-hand side is 1 unit squared. The right-hand side, when I square 2, what do I get? One more time. When I square 2, what do I get? Good. And now when I square the square root, what do I get? Excellent. Good. The right-hand side. The left-hand side now. Before you say anything, I want to prevent any mistakes. I want to show you this again. Put this page by your bedside. Look at it before you go to bed. Look at it when you wake up. Please. So can anyone give us the left-hand side?
The x squared minus 14x plus 49.
Very good. So 49 minus 14x plus x squared. I wanted to show it in that particular order, but you are absolutely correct. The correct sequence is in descending order, x squared minus 14x plus 49. Excellent.
Does it matter what order?
No. I just wanted to show it so no one is confused about this.
Gotcha. Thank you.
But of course I'm going to rearrange it. Of course. So x squared minus 14x plus 49 equals 4x plus 4. I subtract, and I set everything equal to 0. So x squared minus 14x, but I bring a negative 4, negative 18x. And I have 49, and I bring a negative 4, and I get plus 45. If factoring does not take more than 15 seconds, I'll use it. If it takes more than 15 to 20 seconds, then I'll say I don't need it. I'm going to use the quadratic formula. And let me see if I have my 86 here. I always have to praise this calculator for one feature that I have no idea why they did not put in other calculators. This is a very old calculator, so I think you are younger than this calculator, for sure. So what I like about this calculator is that it has a feature called poly. It's a T86. For some reason, I don't think they manufacture it anymore, and this is such a useful feature. I don't understand why they didn't put it in the newer ones. So in this poly feature, second key and poly, you may not see it. Okay. It's asking me for the order. At that time, the degree was called order, I guess. So it's 2. And then I plug in the coefficient, which is 1, in descending order, enter. Then I plug in negative 18, second one. And then the last one, 45. All I have to do is just click on a button that says solve. And I get the solutions. Extremely useful in my opinion. But no other calculator that I've seen, and not the ones that are allowed anyway, have this feature. So, of course, it's x minus 15 and x minus 3, and we have two options, x equals 15 and x equals 3. And I will put as big question marks as I can on paper. Does anyone remember why I put these question marks? What is it about taking both sides to a power, raising both sides to a power? What is it that I put those question marks there? What do I need to do mandatory? Anyone remembers what we need to do?
We need to plug them in and test them.
Must check. Very good. They may not work in the original problem. This is not the original problem. That's not where I go back to. I have to go back to this. And when I plug in 15, oops, when I plug in 15, I realize that no, it's not going to work. Why? The square root has to be a positive number, but this side is negative 8. And this side is 4 times 2, which is 8. No. Now I will plug in 3, and let's see what we get with 3. 7 minus 3 is 4. 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. And I will say yes. So what is the equilibrium point? I haven't finished. The equilibrium point is definitely 3. But then I have to plug in 3, which we already did on that side. It doesn't matter which side. It's 4. But remember, this is 3,000 and 4,000. That's the equilibrium point. That's where they intersect. So they intersect when x is 3,000 and y is 4,000. Now, I would like to hear from you. Do you think we should look at other supply and demand, or we move on to chapter 1?
Can you do 91?
91? Very good. So let's take a look at 91. Same page. 65. And we have the demand of x is x minus 3 squared. And the supply of x is x squared plus 2x plus 1. So very good pick. Same question. We are asked to determine the equilibrium point. So we will set again them equal to each other. So x minus 3 squared equals x squared plus 2x plus 1. So what do we do? This is very clear. There's nothing I should do over there, but how do I expand that? And how many terms I get? Before you say anything, I know, I sound like a broken record, I know. I just don't want to hear x squared minus 9. I want to prevent that. Please, don't ever say that. Okay. So then, can anyone give us the left-hand side?
X squared minus 6x plus 9.
Excellent. Luckily, when I subtract x squared from both sides, the quadratic term goes away. I have to move 2x and I have to move 9. When I move 2x, I get negative 8x. Because it was positive, it moved to the other side, it became negative. 9 was positive. When I moved it to the other side, it becomes negative. Plus 1, negative 8. So x equals 1. I go back anywhere. Let's say I go back here. 1 minus 3 is negative 2. Negative 2 squared is 4. So 1 comma 4 is the equilibrium point. So price in dollars and quantity in thousands. So I should write it like that.
So if it says assume that x is less than or equal to 3 in parentheses, does that affect it or anything?
So this is a very good question. So let me look at these graphs. Let's look at those graphs for a second. Let's see what they did that. So the first graph is x minus 3, and that's a demand. And you will see why they said that. So here's the graph of the demand. and the graph of the supply is x squared plus x plus 2x plus 1, which is the same with x plus 1 squared. So it's right here. And they intersect somewhere. See, the reason why they said that we are only looking at this piece is because the demand, as the price goes up, all of a sudden the demand will go up. So, in other words, for $10 million homes, the demand will be huge, which is not possible. So that's why they wanted us to completely disregard this piece. Because by definition, the demand, as the price increases, the demand decreases. So they didn't want us to even think of this piece. Because all of a sudden at 3 million, the demand starts getting higher. At 2 million is almost nothing, but after 3 million, let's say, I just made up the number, the demand for those homes, let's say, increases, which is not the case. So, very good point. So that's why they said, assume that x is less than or equal to 3. Because beyond that point, it's not feasible. Very good question, thank you. Anything else? Can we consider the review done and over with? Can we start chapter 1? Anyone else needs anything? Okay. Chapter 1. It's a long chapter. It has like 8 sections. The entire chapter is called differentiation. I really don't even want to mention this yet because we're not going to get to it today. So what we are going to get to today is limits, 1.1, limits. But even before we talk about limits, where does this come from? So what are we trying to do with this? What is the need of a limit and what is it? So let's take a look at the following graph. Here's the function. And here's a point P. And this point has coordinates x, and you'll give me the y coordinate. And here's another point, which is Q. This is point Q. And I'm going to say that the x coordinate of Q is x plus a little bit. What I'm telling you here is that Q and P are close to each other, but I'm zooming in so I can make my point of what I'm trying to discuss, what I'm trying to talk about. So obviously this is h, lowercase h. H is a little bit. There's an L here and an E here, sorry. Okay, so can anyone give us the y coordinate of P and the y coordinate of Q? Anyone? How much is this? So this is a point on function f of x, and this is the x coordinate, and this is the y coordinate. How do I determine? If I tell you that x is 1, how will you determine the y coordinate for that point?
Is it p of x?
You're saying f of x, correct. Great. The point is p, but it's on the function f of x. If this is x, this must be f of that value. Good. Now I want the same thing for the y value of q. Can anyone give us, say it again?
Would be f of x plus h.
Yes, and we know what that means. because we worked with it before. Okay. I would like to find the slope of the tangent line at P. And you should immediately say it's not possible. And I'm going to erase this because it is. Why would you say not possible? And I would have to agree with you initially, because I don't have 2 points. So I want to determine the slope of this tangent here. But I only have 1 point. So I know y minus y1 equals the slope times x minus x1, as we reviewed sometime last week, I think, the point slope form. But I only have 1 point of this line. I only have the point P, which is x f of x. But if you give me another point anywhere on this line, then I'll determine the slope. This is what I want. This is what I want. I want to find the slope. And then the equation of the line, right? Not just the slope. But I only have 1 point. So here's what we are going to do. We are going to, number 1, in order to find the slope of the tangent and then eventually the equation, number 1, I determine the slope of the line PQ. And you could say, wait a minute, you're not asked to find the slope of the line PQ, and I say, bear with me, please. So this is the slope, this is the line with the slope of the secant, if you want, secant line PQ. Secant does not come from trig. Secant line means a line that crosses a graph in 2 points. Tangent line is the line that touches, shares only 1 point with the graph. That's the tangent. But a line that crosses the graph of a function in 2 points is called a secant line. So I want to determine the slope of the secant line. You can put it in if you want. Secant line PQ. Well, we know this. We even had a quiz on it. So how do I write it? And this is, I'm just trying to unplug my my computer was charged. So can anyone give us the answer? The slope of this line. And we discussed this, and how do we call it? It has a very important name.
Is it like the average rate of change formula?
Yes, the difference quotient. This is the difference quotient, and I don't need anything. I know it's f of x plus h minus f of x divided by h. That's my first step. In step 2, remember what? This is not the slope of the tangent line. In step 2, imagine that Q approaches P. So when I say Q approaches P, I literally mean Q will not be P. Will never overlap P. I say approaches. Okay, fine. So in other words, I'm telling you now that Q is no longer here, but here. And then see here, and then here, and then here, and then here. Not overlapping P, but extremely close to P. So imagine that Q approaches P. Can you please tell me what happens at that moment when Q gets closer and closer to P? What happens to H? So I'm moving Q. Say it again.
When H gets closer and closer
To what?
to P, to X.
If P and Q get closer together, then wouldn't H decrease?
Approach is what exactly? I'm just waiting for a number.
Would it be X?
Very good. Of course. So when Q gets closer and closer to P, of course H gets smaller and smaller and smaller and smaller and smaller. Not zero. This arrow means approaches. I'm going to write it again just to make sure. H does not equal 0. Okay, in step 3. What else happens? So Q approaches P, H approaches 0. Now I would like you to tell me what happens with the slope of the secant line PQ. Again, the same arrow approaches. Approaches what? Okay, so let me show. This is the initial secant line. Q gets closer and closer. Q gets closer and closer, closer and closer to P. So then what happens to the slope of the secant line? Gets closer and closer to the, I'm not saying equal, I'm saying it gets closer and closer to
0.
So as we get closer, as Q gets closer and closer to P, the secant line becomes the tangent at P, approaches. So as the secant line starts here, and Q gets here, and then Q gets here, and then Q gets here, obviously the secant line is so close, not identical, but so close with the tangent line. Is this concept clear? Is it understood how when Q approaches P and H approaches... Sorry about that. Mary, I'm in class. I'll call you back. Sorry. No, I'll call you back. Thank you. Bye. Sorry, it's a friend who's in the hospital. Sorry about that. So as Q approaches P, H approaches 0, and the secant line gets closer and closer to become the tangent line, and therefore the slope of the secant line gets closer and closer to the slope of the tangent line. So what is all this? This is what we call the concept of the limit. This is an operator. Operator. It's the limit operator. So before I put everything else in, let's discuss what an operator is.